This is the 2.6 to 2.9 review, number 3, and calculators still are not allowed on this portion of the review. So if we read the problem, it says, let f be a function given by this absolute value function, x plus 11. The question is, we want to determine whether or not f is continuous, whether f is differentiable, and then we have these two statements here that are analytical variations of these two. So, in my opinion, the easiest way to determine the truthfulness of these four statements is to draw a picture and look at this, because we know continuity means we draw it without picking up our pencil, and differentiability means we draw it without picking up our pencil and we have no corners, cusps, or vertical tangents. So if I draw this function, we can see because we added 11 inside the absolute value that it's going to move the picture vertex back to negative 11. So if I look at this picture, can I draw it without picking up my pencil? And the answer is yes. So this one would be true. The next one says, can I draw it without picking up my pencil and without having any corners, cusps, or vertical tangents at x equals negative 11? So if I draw this, we can see here at negative 11 I have a very abrupt change in direction. I have a corner, so this is not going to be differentiable at x equals 11. The next two items are going to test whether or not you know how to write continuity in an analytical statement. Same thing with differentiability. If we look here, this says I have a y minus a y over an x minus that negative 11. Notice that this is a secant slope, and then I'm applying a limit so that the point x f of x turns into the point negative 11 f of negative 11. So this is a secant slope that turned into a tangent slope, and a tangent slope is the same as the derivative. So this is just another way of saying that f is differentiable at negative 11. And we already decided in step 2 that that is not the case. The final step says that the y coordinates are getting close to the output of the function as x approaches negative 11 from both sides. So if I hop on my curve and I move left and right from negative 11, we can see that not only are my fingers meeting and I have a limit, but it's at the same place that the function assigned the output for negative 11. So if we recall, this is just another way to say that f is continuous at negative 11. So this is synonymous with number 1. So these two are true because we drew it without picking up our pencil, and these two are false because we had a corner.